Is a screen visible to all of you? Today we are going to see next unit, divide and conquer. Before starting the unit, may I know, is there any difficulty in chapter first from your side? Or any part is remaining? Hello? So today we are going to see next unit, divide and conquer. In the chapter, we'll see the general method. This is the contents of this chapter, that is general method, binary search, finding maximum and minimum, then quick sort, selection sort, and merge sort. Okay. Then textbook for this chapter is Fundamentals of Computer Algorithms by Horowitz, Sartaj Sahani, and Raj Shekaran by Galgotia Publication. Then course outcome. At the end of this chapter, student will be able to select appropriate algorithm to design paradigm for a particular problem. Then about the title of the chapter, that is divide and conquer. Whenever you solve any problem, if the problem is easy, then solve directly. If problem is difficult, then divide the problem into sub parts and solve that sub parts and recombine the solution of that sub parts. That is divide and conquer. That is make a group of people disagree and fight with one another so that they will not join together against one his military strategy, that is divide and conquer. This is the general definition, not a technical. So what is the central idea of this chapter? The divide and conquer paradigm is often used to find optimal solution of the problem. The basic idea is decompose a given problem, that is do the different part or small parts of that particular problem, two or more but simpler sub problems, and to solve them and again combine their solution for that particular problem. This is the central idea of this chapter. Then why this chapter is important? This chapter is important to find an optimal solution of particular problem. Whenever the problem is difficult, then divide the problem into smaller subparts, solve that subparts and recombine that. Here in the chapter, in quick sort, selection sort, insertion sort, we are going to see the same method. And what is prerequisite for the chapter? So data structure, which cover abstract data types such as stacks, queues, and searching and sorting techniques. These are the prerequisite for the chapter. Okay, before going to see or actual start of this chapter, I will give one example to solve. Okay, solve this example. Find the value of that variable x, that is x square minus 13x plus 36 is equal to 0. Find the value of x. Roll number A8. What is the value of x? Roll number B12. Anybody? What is the value of x?
9 and 4.
X is equal to 9 or 4. Okay, you have solved this. Suppose instead of this example, I have given like this: x raised to 4 minus 13x minus 13x square plus 36 is equal to 0. For this example, roll number 828, B77, that is For solving this example, you have substituted, suppose x square is equal to p. Before this, you have done x raised to 4 means x square square minus 13x square plus 36 is equal to 0. So you have substituted here same term. So put x square is equal to p. That means you will get new equation p square minus 13p plus 36. So you will get value of p. P is equal to 9 or 4. So put value of p, that is you have substituted, you have put x square is equal to p. So put p is equal to 9 or 4 in equation 1. So here you will get x square is equal to 9 or x square is equal to 4. And therefore, after taking square root, you will get x is equal to plus minus 3 or x is equal to plus minus 2. Are you getting?
Yes, sir.
Suppose instead of this example, I have given next example like this. X raised to 8 minus 13x raised to 4 plus 36 is equal to 0. Then here you should put x raised to 4 is equal to p. Then here x raised to 4 bracket square minus 13 x raised to 4 plus 36 is equal to 0. So p square minus 13p plus 36. Therefore, after solving this quadratic equation, you will get p is equal to 9 or p is equal to 4. Put these values in equation 1. Suppose equation 1 is equal to x raised to 4. So x raised to 4 is equal to 9 or x square x raised to 4 is equal to 4. Then here x square square is equal to 3 square plus minus 3 square or x square square is equal to plus minus 2 square. So taking square root, you will get x square is equal to plus minus 3 or x square is equal to plus minus 2. Then again taking square root, you will get x is equal to plus minus under root 3 or x is equal to plus minus under root 2. Okay. In these three examples, first example is x square minus 13x plus 36. This quadratic equation you have solved directly because it is easy and it is a small as compared other two. So if the problem is a small, then solve as it is or solve easily. If problem is difficult, then divide that problem into sub problems, find their solutions and recombine their solutions so that we get the final result of given problem. And this is the aim of this chapter. Are you getting? So divide and conquer, that is D and C. Divide and conquer, it is one of the strategy to design a algorithm. Suppose you have to design a particular algorithm of addition of two numbers. What to do? Suppose I want to write program for this code or algorithm for this program, then what is the procedure? Here, first procedure, start, then take any two numbers, then do addition, and then addition will be stored in third variable and display the value of their addition with the third variable and then stop. This is the algorithm. While writing this algorithm, you have divided into number of steps. That is, first step is a start. Second, take any two numbers. Third, do addition of that numbers or add, take any two numbers A and B, then add A and B. Fourth, display addition, and fifth, stop. So while writing algorithm, you should have to see if the algorithm is easy, you can write directly. If algorithm is difficult, then divide into subparts. Okay. And divide and conquer is a technique that the problem is decomposed into number of smaller parts, and then smaller instances are solved independently. In previous example, you have seen that is in this example, x raised to 4 minus 13 x square plus 36. In this example, you have seen that the steps. So here you have substituted or put x square is equal to p, then p square minus 13p is equal minus 13p plus 36. You have solved this statement, you will get p is equal to 9. That is x square is equal to 9. You have solved again independently. So whenever there is a big problem or while writing a big algorithm, divide the part into sub parts, solve independently, and then recombine their solutions. Okay, we'll see first algorithm, that is divide and conquer of problem. Name of the algorithm, we'll see first algorithm, divide and conquer of problem. So in this, if p is small, if p is small, then return with the solution of p, that is sp, solution of that problem. Else, if problem is big, then divide the problem p into smaller sub problems. smaller sub problems such that P1, P2, P3 up to Pk. Then again apply divide and conquer algorithm to solve these sub problems. That is divide and conquer for P1, divide and conquer for P2, then divide and conquer for P3 up to divide and conquer for Pk. Then recombine their solutions of, that is S solution of SP1, SP2 up to SPK, so that we get the final answer of that problem. This is the first divide and conquer algorithm. See this algorithm carefully. And in this problem, this P denotes problem size. And here S of P, that is solution of the problem. See this algorithm carefully. Okay, anybody have any query regarding this algorithm? If the problem is small, you can directly solve. If the problem is large, divide the problem into sub parts or sub problems such that P1, P2 up to Pk, and apply same algorithm to solve these sub problems. Then find their solutions, and then lastly recombine their solution. See, in this algorithm, we have used a recursive algorithm. The recursive algorithm which we have studied in chapter first. See here, see the name of algorithm, that is divide and conquer. P, same name is used in this algorithm here, in this part, that is apply divide and conquer algorithm to solve, that is same algorithm is used here for solving problem first, problem second, and up to problem K. So in this chapter we are using recursive algorithm, use of recursive algorithm. Next, if the size of problem P is n, if the size of problem P is n and sizes of k subproblems. Suppose this is a problem P and its size is n, and this problem P is divided into k subproblems such as P1, P2 up to Pk. So the sizes of these subproblems is n1, n2 up to nk. So what is the time required for solving this problem? So t is a time and size of that problem, that is n. T of n, time is required to solve this problem P is T of n, which is equal to G of n if n is small. This time required to solve problem P with size n is equal to G of n if n is small, and if n is greater, that is the time required to solve these n, T of n1 plus T of n2 plus T of n3 plus up to T of nk plus f of n if n is not small, that is n is big, or we can write otherwise condition. If first condition is n is small, you can directly write answer G of n. If n is not small, that is this condition dissatisfies, then divide that problem into sub problems with sizes n1, n2, n3 up to nk, and then time required for solving this T of n1 plus T of n2 up to T of nk plus f of n. This is the general statement for time complexity. This is the general statement for the time complexity. Are you getting? Are you getting? Roll number 820. A44. Are you there? B29. Are you getting or not? We'll see once again. We'll see once again. See here. If n is the size of the problem, that is, there is a problem, suppose P, and having size n, Okay. Then if the problem is small, solve as it is. Okay. If the problem is big, then divide that problem into sub problems such as P1, P2, P3 up to Pk. If n is the size of the problem, then n1 is the size of problem subproblem P1, n2 is the subproblem P2 up to nk is the size of subproblem Pk. Okay. If T of n is the time complexity for solving the problem, if T of n means that is size of the problem and T means the time complexity. So time complex T of n is a time complexity for solving the problem P. It have two answers. First answer is G of n. If n is small, if n is small, then you will get answer G of n. Then if n is not small, then time complexity of n1 plus time complexity of n2 up to time complexity of nk plus f of n. This is otherwise. Okay, see the screen carefully. Hello, are you getting? Is there any problem? In general, we can write a time complexity of a particular problem. We can write that is a T of n is equal to T of 1 if n is equal to 1. If n is equal to 1 and otherwise a into T of n by b plus f of n. This is if n is greater than 1, where A and B are known constants. This is if n is equal to 1, then we can write instead of g of n here, we can write t of 1. If n is greater than 1, then we can write a into t of n by b plus f of n, where a and b are known constants. We'll see one example on this. If suppose a is equal to 2, b is equal to 2, then t of 1 is equal to 2 and f of n is equal to n. Then find t of n. Here the values of a, b, t of 1 and f of n are given, and here we should have to find value of t of n. So we'll put the values in this equation. Now here n is greater than 1. First we consider here n is greater than 1, so we can directly write t of n is equal to a into t of n by b plus f of n. We put the values of a, b, and f of n. We get 2 t into t of n by 2 plus n. This is t of n, suppose equation number 1. Now put n is equal to n by 2 in equation 1. So t of n by 2, instead of n we can write n by 2, which is equal to 2 t n by 2 upon 2 plus n by 2. So we'll get t of n by 2, which is equal to 2t n by 4 plus n by 2. This is equation number 2. So from equation 1 and 2, the value of t of n by 2, value of t of n by 2 put in equation 1. So we get t of n is equal to 2 in bracket t of n by 2 is equal to 2 t of n by 4 plus n by 2 plus n from here. I will repeat once again. Here I will write equation 1 as it is first. T of n is equal to 2 t of n by 2 plus n. Okay, then I will put value of t of n here 2 as it is, then value of n by t of n by 2 I'll put as it is in this bracket 2 t of n by 4 plus n by 2. This is the value of t of n by 2, then plus n. So multiply by 2 in this bracket, we'll get 4 t of n by 4 plus 2 n by 2 plus n. So we will get t of n is equal to 4 t of n by 4 plus these two and these two gets cancelled. We'll get n plus n 2n. This is suppose equation number 4. Equation number 3. Now put n is equal to n by 4. N is equal to n by 4 in equation 1. So I will write first equation 1 as it is. So t of n is equal to 2 t of n by 2 plus n. So 2 t here instead of n by 4. So here n by 4 divided by 2 plus n by 4. So which is equal to 2 t of n by 8 plus n by 4. This is the value of t of n by 4. This is equation number 4. See these equations carefully. Now, from equation 3 and 4, that is put value of t by n by 4, t of n by 4, put value of t of n by 4 in equation 3. We get, I will write first equation 3 as it is. T of n is equal to 4, t of n by 4 plus 2n. So 4, then put value of this in bracket 2t n by 8 plus n by 4 bracket complete plus 2n. So multiply by 4 to this bracket, we get 8 t of n by 8 plus 4 into n by 4 plus 2n. So we get 8 t of n by 8 plus this 4 and this 4 gets cancelled. 8 n plus 2n, that is 3n. Okay, so we'll see the relation of these 8 and these 3. Instead of 8, we can write 2 raised to 3 t of n upon 2 raised to 3 plus 3n. Okay, so we can write in general 2 raised to I t of n upon 2 raised to I plus n into I. Are you getting? And this value of I lies between where I lies between, that is 1 is less than equal to I is less than equal to log 2 raised to n. 1 is less than equal to I is less than equal to log 2 raised to n. So instead of I, we write the value of, here we are taking I equal to log 2 raised to n. We'll put in this equation, we'll get t of n is equal to 2 raised to log 2 base log of 2 raised to n of into t of n upon 2 raised to log of 2 raised to n plus n into log of 2 raised to n. Okay, we know the formula as b raised to log of a raised to b. We know the formula b raised to log of b raised to a, that is we can write a into log of b upon log of b, which is equal to a into 1, which is equal to a. We can directly write. Similarly, in here 2 raised to log of 2 raised to n, we can directly write n, that is n into log of 2 upon log 2, which is equal to n, into 1, which is equal to n. So the equation will become as t of n, which is equal to n into t of n upon n plus n into log of 2 raised to n. So which is equal to n into t of 1 plus n log of 2 raised to n. And here t of n value is given, that is t of 1 is equal to 2, value is given. So n into 2 plus n log 2 raised to n, and therefore the time complexity of given problem, that is 2n plus n log 2 raised to n. This is the final answer. हॅलो, आर यू गेटिंग? समजलंय का तुम्हाला? रोल नंबर A3, A44, B20, are you there? repeat once again. If the problem is P with size N, size of this problem is N. If N is a small, then solve directly. If N is a large, then divide the problem into sub problems such as P1, P2 up to Pk. If N is the size of that problem, then after dividation, the size of each sub problem is, for P1, size of P1 is N1, size of P2 is N2, size of P3 is N3, up to size of Pk is Nk. Okay. Then the time complexity of solving this problem is T of N, where T is the time complexity and N is the size of that problem. So T of N is equal to G of N if N is small. If N is small, otherwise T of N1 plus T of N2 plus T of N3 plus T of Nk plus f of N. This is for otherwise. Here P is the problem and N is the size of that problem. If N is a small, then solve this problem as it is. If problem is large, then divide this problem into subparts such as P1, P2 up to Pk. So if N is the size of the original problem, then the size of the sub problems are, for P1 size is N1, for P2 size is N2 up to for Pk size is Nk. Then time complexity of the problem, T of N is equal to G of N if N is small. If N is large, then T of N1 plus T of N2 plus up to T of Nk plus f of N. If N is a small, we can write G of N is equal to T of 1 as it is, and for T of N1 plus T of N2 plus T of N3 plus T of Nk, we can write for this A into T of N by B. So this T of N will become as so T of N is equal to, instead of G of N, we can write T of N or T of 1 if N is small. And instead of this series, we can write A into T of N by B plus f of n as it is. This is for otherwise. Okay, we will see the problem on these. Suppose you have given in the statement a and b are known constants, and you have given a is equal to 2, b is equal to 2, t of 1 is given as a 2, and f of n is equal to n. You should have to find t of n. So here f of n is given, value of a and b is given. So we consider n is large. First, we consider n is large. So we get the equation t of n is equal to a into t of n by b plus f of n. We substitute the given values. We put the given values of a, b, and f of n in this equation. We get t of n, which is equal to 2 into t of n by 2 plus n. Suppose this is equation 1. So in this equation, we should have to find value of t of n by 2. So put n is equal to n by 2 in equation 1. So we get t of n by 2. Instead of n, we are putting here n by 2. We get 2 into t of n by 2 upon 2 plus n by 2. So we get 2t into n by 4 plus n by 2. So t of n by 2. Suppose this is equation number 2. So put t of n by 2, t of n by 2 in value of t of n by 2 in equation 1. So here we get t of n, which is equal to 2 into t of n by 2. Put this value. So 2 t of n by 4 plus n by 2. Then original here from equation 1 n. Okay, see the screen carefully. If anybody have any query, please ask. Okay, then next step, So we get T of n is equal to do the multiplication. Here multiply by 2 into this bracket. So we get 4 T of n by 4 plus 2 into n by 2 plus n. So we get 4 T of n by 4 plus here these two gets cancelled, n plus n, that is so 4 T of n by 4 plus 2n. So we will see the relation between these 4 and these 2, that is we can write 2 raised to 2 T of n by 2 raised to 2 plus 2n. Instead of these two or these two, we can write I. So 2 raised to I into T of n by 2 raised to I plus n into I, where this is a T of n, where 1 is less than equal to I is less than equal to log of 2 raised to n. So we put value of I here, since first we have taken n is large. See here we consider I is equal to log of 2 raised to n. We'll putting the value of I in T of n. So T of n is equal to 2 raised to log 2 raised to n into T of n by 2 raised to log 2 raised to n plus n into log 2 raised to n. So we know the formula that b raised to log of b raised to a, which is equal to a into log b upon log b, which is equal to a into 1, which is equal to a. Similarly, we can write 2 raised to log 2 raised to n, which is equal to n into log 2 raised to 2, that is n into log 2 upon log 2, which is equal to n into 1, which is equal to n. So instead of 2 raised to log 2 raised to Okay. So this equation, see, this equation will become see this equation will become as, I will write, instead of 2 raised to log 2 raised to n, we can write n into t of n by n plus n log 2 raised to n. So here n into t of n by n, that is this n gets cancelled, t of n plus n log 2 raised to n. So here value of t of 1 is given, that is a 2. So n into 2 plus n log 2 raised to n. So we will get the time complexity of the given problem 2n plus n log 2 raised to n, or we can write taking common n into 2 plus log 2 raised to n. This is the time complexity of given problem. See the screen carefully. Okay, are you getting? इथपर्यंत समजलंय का तुम्हाला? हॅलो, the divide and conquer in this chapter we study, that is divide the problem into small sub problems. If suppose this is a problem P, if this problem is solved and if it is easy, then solve as it is, you will get answer. If this is this problem is difficult or it is lengthy, then divide this problem into sub problems, that is problem P1, P2 up to Pk. Okay, so while writing the algorithm on this, that is divide and conquer algorithm for problem P, so first you should have to check if the problem is small, then return the solution. Return the solution of this problem. Otherwise, that is else, divide the problem into sub problems such as P1, P2, P3, P4 up to Pk. Okay, then again apply divide and conquer algorithm to these sub problems. Again apply divide and conquer algorithms to these sub problems, that is divide and conquer of P1, divide and conquer of P2, divide and conquer of P3, divide and conquer of Pk. Then recombine their solutions, that is solution of P1 plus solution of P2 up to solution of Pk, so that we get the final result of given problem. This is the divide and conquer algorithm. In this algorithm, we have used the recursive algorithm. The recursive algorithm concept we have seen in chapter first, the algorithm which is called by itself again. See in this is the name of the algorithm, divide and conquer of problem P. In this algorithm, same algorithm called again divide and conquer of P1, divide and conquer of P2, divide and conquer of Pk. So here in this algorithm we have used the same algorithm, that is a recursive algorithm. Okay, if the problem is small, then solve as it is. If problem is large, then divide that problem into sub problems. Again see, problem is, suppose in case of problem P1, again see The problem is problem is small, then solve as it is. Again, this problem is large, divide into sub problems, that is P11, P12 up to P1K. Similarly, check problem P2 is small, then solve as it is. Otherwise, divide into sub problems P21, P22 up to P2K. In the same way, here same PK1 up to PKK. Okay. Then what is the time complexity? In general, time is required to solve a particular problem or particular algorithm. So the time complexity of that problem is find out. Suppose with their size, suppose the problem P with size n is the size of this problem. If n is a small, then solve this answer, solve this problem. So time complexity of this problem T of n is equal to G of n if n is small. If P of if problem P is large, then divide into the sub problems. So P1, P2 up to Pk. If n is the size of this problem, then size of P1 is n1, P2 is n2, and size of Pk is nk. Then time complexity of these is T of n is equal to T of n1 plus T of n2 plus T of nk plus f of n. This is for otherwise. And we can combine these two equations, this equation and this equation. We get T of n, which is equal to G of n if n is small. If n is small, if this condition becomes false, then the statement T of n1 plus T of n2 plus T of nk plus f of n, this is for otherwise. And instead of this series, we can write a into T of n by b and plus f of n as it is. Up to this, clear? Is there any query? Hello. Today we have seen the concept of divide and conquer. In this introductory part, we have seen that if the problem is small, then solve as it is. For example, first example I have given, that is x square minus 13x plus 36 is equal to 0. So it is easy to solve, that is you will get x is equal to 9 or 4. So this problem is a small. So if problem is a small, then find the solution. Okay, solution of this problem. If problem is large, that is suppose x raised to 4 minus 13x square plus 36 is equal to 0. So you should have to divide here x raised to 4 into this part x square square plus 13x square plus 36, and then here x square, then you should put x square is equal to p, and then you will get a new quadratic equation p square plus 13p, okay, p square minus 13p okay, p square plus 13p plus 36, whatever. So after solving you will get p is equal to minus 9 or p is equal to minus 4. So same case here, if problem is small, then find the solution of that problem. If problem is large, divide that problem into sub problems, that is problem sub problem p1, sub problem p2 up to sub problem pk. Again, while solving this sub problem, if it is small, then find the solution sub problem, solution of sub problem 1, sub problem 2. If the sub problem is large, divide these sub problems into again sub problems, that is p of 1 1, p of 1 2 up to p of 1k, and then find the solution of these sub problems and combine all the solutions so that we get the final solution of that problem. Are you getting? The same concept applied here. So while solving any problem, if the problem is small, then solve as it is. If the problem is large, then divide the problem into sub problems and apply the same concept while solving the sub problems again. Okay, so in last chapter we have seen binary search. So suppose you are inserted array, that is 11 12 or 13, which is in ascending order. So if I want to search number 17, then first you should have to find the mid, that is here mid of this is 14. Whenever you find mid, there are the three parts. This is left sub array, this is a right subarray, and this is the mid. Then first we compare the search key with this mid. If the search key is exactly equal to mid, then search is complete. If search key is less than mid, if search key is less than mid, then search the particular number in left sub array. If search key is greater than mid, then search the particular number in right sub array. Apply the same condition, finding mid, that is assigning low, high, and mid. Okay, so while finding a mid, you have assigned low is equal to 0, high is equal to mid, high is equal to size minus 1. Then you have find mid. Similarly, while the number in left subarray or right subarray, then in left subarray, low is equal to 0, high is equal to mid minus 1. Then find new mid. If number in right subarray, then low is equal to mid plus 1. Then high is equal to high, that is size minus 1. And find the new mid. The same procedure apply. So divide this array into sub arrays so that we can find a particular number. This is the concept of divide and conquer. Okay. The next part is binary search. With the help of divide and conquer, we are going to see in next lecture. Okay, we'll stop here.